Hello my friends and welcome to our next video. This is a key skills for chemistry video focused on balancing equations. So let's first look at why we need to balance equations before we find out how we can do it. Well, first off, we need to because we cannot create matter out of nothing. So when we're writing simple equations, we need to make sure that everything has coming out as a product has been put in as a reactant. And we also cannot destroy something. So again, if we're putting something in as a reactant, it must come out in our products. It cannot disappear. Everything that we're putting in as reactant simply goes through a changing bonding and structure to change its shape or its composition or maybe its state. And finally, the most important part of all of this is that because everything is made of atoms, whether we're getting gas, whether we're getting liquids or solids made out of it, will always have the same mass going in as the mass coming out. So we should never get a setup like this where we've got scales where they are tipped towards the side of reactants or products in terms of their mass. They should be absolutely flat even if gases are involved. I mean, if you had it there on a weighing scale on your balances, you would see that the mass is decreasing as bubbles of gas are being produced in your solution if you're reacting a metal and an acid. But really that mass is still there. It's just as a gas, and so therefore it's not weighed by your scales. So let's get into how we can do this balancing of equations. So you get a setup like this. This is our symbol equation, and it needs to be balanced. And the examiners will ask you, or you'll need to do in class, you'll need to balance it. So how do we know that it's unbalanced in the first place? Well, first what I would do is after you've got your symbol equation, I would write underneath your reaction arrow, which shows the progress of the reaction. I'd write out the types of atom that we have. So we've got hydrogen, we've got oxygen. So I've written my hydrogen, my oxygen. I've just taken them from there, and just double checking that they're also on the product side, which they are. And what I'd then do is to the left and the right of this, I'd count up how many I have for reactants and how many I have for the products. So for hydrogen here, I have H with a little 2 next to it, which means I have 2 of those hydrogens. And for the oxygen, I have again O2, so I have 2 of the oxygens. And for the water, the H2O here, again I have H with a little 2, which means that we have 2 of that first thing, and we have nothing written next to the oxygen, which means that there is just 1 of those. So 2 hydrogen and 1 oxygen. And as we can see, these are not equal on each side. We have more oxygen on the left than we do on the right. We have the same amount of hydrogen. And if we were to visually represent this with molecules, we've got 1 oxygen molecule, which is oxygen bonded to oxygen, and 1 hydrogen, which is a hydrogen bonded with a hydrogen. And on the right hand side, we have 1 oxygen bonded to 2 hydrogens, which is our water molecule, but we're missing a whole extra oxygen atom here. So that's the problem we have. Let's see how we can work it out so we can solve this problem. So the first thing we need to check here and need to make clear is that we cannot change the small numbers after each element symbol. So we cannot change this 2, the 2, the 2, or the 1 here for the oxygen. We cannot change those because that would be changing the chemical structure of any of these molecules. So if we wanted to make it into H2O2 to balance this, for example, we cannot do that because that would be changing the whole structure of our molecule. So we cannot just add an extra oxygen atom into this molecule. We cannot do that because it changes the whole chemistry of the thing and it just won't work. But what we can do is we can change how many of each of these molecules we have. So we can, for example, have 2 hydrogen molecules. So we could add another whole hydrogen molecule to this reaction, or we could change that and make it out 4. Why not? We could have 4 hydrogen molecules, meaning that we'd have a total of 8 hydrogen atoms. So we could do that. That's the thing that we can do with balancing equations. We can't change the small numbers, but we can write large numbers in front of the whole molecule to change how many molecules are in the whole equation. So let's see how we could do this for the first example. So our issue is that we have more oxygen on one side than the other. So it's tempting to get rid of this 2 and just say, okay, we've got 1 oxygen, it's balanced. But again, that's changing the molecular structure of oxygen, which we cannot do. What we can do is we can say that we've got more molecules of water. So let's do that, let's try that. So start off easily, just doubling how much water we have. So now we have 2 water molecules. So we have now got an extra oxygen and an extra 2 hydrogens. So oxygen now is balanced. Really good, happy days, that's balanced now. But we've created a problem for ourselves where we now have more water molecules. So now we have 2 times by the H2 and 2 times by the O2. The O on its own, sorry, not O2. So now our hydrogens are not balanced. So how we can rectify that is we can look on the left-hand side of the reaction, we can look at the reactants, and we can change our hydrogen over here, and we can double that to give us a balanced simple equation. It's fully happy and balanced now. We've got 2 extra hydrogens on the left side. So we have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens on the right, and then we have 1, 2 oxygens on the left and 1, 2 on the right. So our scales are now absolutely balanced. So 2 hydrogen, we've got effectively 1 oxygen there, or we haven't written a number, but it could be that it's just 1. That's what it just means by not writing a number there. And we have 2 water. 2 numbers would give you 1 or 2 marks in the exam question. Here's another example. So in this we have 2 hydrogen on the left hand side, 2 nitrogen, and on the right here we have our N with no number, so it's N1 and H3. So we've got 2 systems here, 2 of the atoms are actually out of balance. And if you were to work logically down this, you could maybe look at hydrogen first and trying to balance that, but it gets a bit complicated because we've got H2, we can't double that to make H3 because it won't work. So let's look at the nitrogen first and see what we can do with that. So we've got too much on the left and not enough on the right. So a nice logical place would be to start by doubling how much we have on the right, because our nitrogens are equal. So that gives us 2 nitrogen, but it also gives us 2 times by the 3 of hydrogen, which is now 6 on the right hand side. So our nitrogens are now balanced, good, and on the hydrogens, however, are not. So what can we do to this hydrogen on the left hand side and the reactants to get to 6? Well, we could triple it. We could give it 3. So we've got 3 hydrogen molecules. That gives us a total of 6 hydrogens, and there are 6 hydrogens on the left hand side, so those are also balanced. That one was lovely. And the final example I wanted to give you here, we have a system where we've got brackets, and the brackets just mean that anything in these brackets are multiplied by the number afterwards. So we've got 2 of oxygen and 2 of hydrogen. So let's total up how many we have again. We have calcium on the left, 1, calcium on the right, 1. Hydrogens on the left, we have 2 there. Hydrogens on the right, we have 2 times by the 1 in the brackets, which is 2, plus the 2 here on as well. So there is a total of 4 on the right hand side. Oxygens, we have 1 on the left, and we've got 2 on the right. So again, we've got a situation where we need to balance. A nice place to start would be trying to even out. Well, we've got not enough hydrogens on the left and not enough oxygens on the left. What do we need to do? Well, we need to double the hydrogens and we need to double the oxygens. So we could do 2 water molecules, which gives us now 4 hydrogens and 2 oxygens. And we're balanced. That was simple. Lovely. So now that we've spoken through some of the rules and I've shown you how you can do it with the method of writing out the number of atoms either side of the equation below the arrow, you can try it for yourself. So pause the video here, try the calculations. They get progressively harder. If you can get down to number 5 and 6, brilliant. If you can do up to 3 and 4, that's probably GCSE standard. Good luck. And here are your answers for checking. Give yourself a pat on the back if you got it right. And if you've got any questions or queries about any of the things that we've gone through, or you wanted to give me a challenge of a simple equation to balance, just give me a shout in the comments, and do like and subscribe and check out the other Key Skills Chemistry videos.